Click it again.
Jeff would have been very mad at me.
Yes, he would have.
Oh, the other day.
All right, welcome to the August meeting of the BBAA. First, we're going to start out with the Vice President's report.
Okay.
So
better.
let me, you're going to come up here, right?
Yeah, I'm coming.
Hey, can you share, Rich, can you let us share the screen? It says it's disabled.
Yep, I'm doing that now.
Okay. You know how to do that.
Thank you.
You should now have the power.
Okay. All right, now I got to share it. Wait a minute. Oh,
Yeah, you're back in here.
yeah. Now share.
There you go.
Okay. This is the August schedule. Right now it's the 4th for us. Can everybody hear me okay, Rich? Am I coming out?
Yeah, we hear you.
Yeah, yeah, I'm coming out. Okay, the Friday of the 5th is family stargazing at 4th Story at 9 o'clock. I don't know if y'all can see it okay. We got Boardwalk Astronomy on the 9th. That's number 4. If anybody, we'll give some more information about that too, because it's a real good event for the public. And it's free, of course. We bring our telescopes out to the boardwalk on 25th Street, 24th Street. I always get it mixed up, 2401 Atlantic Avenue. And you can only have so many passes for cars on the beach. So you got to get there on or before 6 p.m. Okay, and it's great. It's a great event. Lots of public, and this will probably be the last chance the public will get to see us. Is there one more meeting? I think in
No,
September.
was last
September is one more. That's right. Okay, so back to this. And that's Boardwalk. They canceled the Boys and Girls Club. I don't know what happened. Maybe you can fill us in. This is canceled. George, I'm asking George. I don't know. Okay, well, we'll investigate the Boys and Girls Club on the 12th. Saturday, Sunday on the 10th is at 13th is Elizabeth River Park. And we got Skywatch at 7 o'clock Northwest River Park.
Yeah, Cornwatch on there.
I'm not logged in.
Cornwatch is not on here. We'll fix
I'm
it.
not logged in.
Do you know,
Oh, okay, so Cornwatch and Nightwatch are not on there because he's not logged into the Night Sky Network.
Right.
Only members can see Cornwatch and Nightwatch.
that's true. Maybe I can switch it over, but that's all right.
That's all right.
You know what, do you remember? Is it the 27th?
Why is that?
Because it's a club member only.
Members only.
Well, I guess we should cover these other topics though.
Okay,
I'm not logged in on there, but I'm logged in on my phone. You got
okay.
Here, I can pull it up.
the VA Regency Society.
All right, I'll
Bacon's
stop
Castle.
sharing. Let you share the screen for the calendar. Can you do that, Rich?
Yep, I'm going there now.
Check.
Yeah, and then you just read it. I need to change my password. I tried to log in. It's like, that's not possible.
Oh, really?
Yeah, but it's saved in my phone, so I can just.
Yeah.
Okay, March.
All right, now see if you can make it bigger with control. There you go. My man, that's too big right there. That's good. Okay, where are we? Here we go.
Yeah, so you
The Bacon's Castle thing, yeah. Saturday, Sunday, and that on the same day, Thursday, is 7 p.m. Skywatch Bacon's Castle.
You click on it.
Yeah.
Pull the details of that.
If anybody has any questions, I clicked on it, but didn't.
Oh, you can't do it.
I can't
Rich,
click
you
on
can.
It's my screen, Jeff.
That's right. You have to click on it.
You want me to click on it? I'll click on
Yes,
it.
sir.
This is awkward.
It doesn't do anything when I'm clicking.
All right, that's okay. But Bacon's Castle.
Oh, there it is.
Bacon's Castle's a really huge farm, or it's a farm really. And there's a house there from the 1700s or 1800 style, but I believe it's 1700s. The house was built at Bacon's Castle in Surrey. So anyway, that's going to be a good event for us.
Now you can see from the description, you know, the people like to dress up like in the style of 1800s, and they're also going to talk about astronomy, and they're having real amateur astronomers also there to show the night sky.
Coincides with the Perseids meteor shower,
So, no,
which is the
that's-
biggie.
That's gonna be a bright moon that night.
Of course, we can't, bright moon, that's what we need. All right, so that's the 20th, and I don't see the moon on here at all. They just left it off. This is Leah's
This is
login.
Rich.
Oh, this is Rich, you don't have the moons?
Apparently not.
Okay, I have it on mine. Night watch is on the 27th, and that is that's it. Where's
You
that?
you go back here to Jeff, so this one, Nature Bus.
14th, you skipped a week.
Skip nature,
You skipped the
nature
whole
bus.
week.
I'm sorry. Northwest River Park Skywatch is on the 20th, but before that, the 14th, nature bus, and I don't know anything about nature bus.
Yeah, I get on the nature bus, I give them a little presentation on their computer screen on the way to Cornland. And then we get off and look at usually have 2 or 3 other guys there, and we look at the stars and planets.
Cool. All right. And that's at Cornland Park. Benefit Road, there's the address 2908 Benefit Road. Okay,
And then there's Corn Watch. Which
And
goes
and
out-
Corn Watch is right here on
25th,
the Croatan Beach.
I just added that.
Okay, it's recent. Croatan Beach Galaxy Gaze, can you tell us more about it?
Yeah, there's just the community there at Croatan Beach. We asked if we could come out and show them the sky. We did this several years ago and it went over really well. Haven't done it for several years. I asked for 2 or 3 other astronomers to come help. We could park in the person's driveway and walk between the houses, take our telescopes out to the beach, just show them Saturn might be up, and some other things in the east in the dark sky. They're going to try to get people to turn out their lights along the beach.
Very good. Okay, and that's there's the address 504 South Atlantic Avenue. Okay, and we'll switch it back to the calendar. Thank you. And then Skywatch Northwest River Park, that's our public event that we have to show the public the sky, and it's the equestrian area. That starts at 7. And let's see, what am I off by a week here? Croatan and then Corn Watch at Cornland. That's members only for those that like to shoot pictures and take long exposures without public. Night Watch goes all night. And that one is at
Folks,
Chip Oaks River Park. Chip Oaks, not River Park, Chip Oaks State Park. All right, and that goes all night on the 27th through the 28th. Club meeting again on the 1st of September. And I think I'm sure that'll be here. Great Navy Camp Out on September 3rd. And we'll,
this is Breezy Point Park on Norfolk Naval Station.
okay, can you just switch to the next month? Thank you. All right.
We just set up a telescope.
These are all our normal ones.
Right.
Special events, yeah.
Okay. And all this is on Night Sky Network if you'd like to look at it. 6 o'clock, another boardwalk number 5.
Number 5.
5, that's the last one.
Why the numbers don't show up.
That's funny.
Yeah, well,
And Saturday, Sunday on the 10th. Corn Watch 16th, which is the Friday before Skywatch, Northwest River Park. Corn Watch again on the 23rd. Now we see the moon.
I get the moons now.
Yeah, me too. Did I? Okay, never mind. I don't want to tell that joke. And then Night Watch starts the 24th through the 20th. You guys were thinking it, weren't you? Okay. And that's all I got for you. Anybody have any questions?
The last of this year's supermoon is on August 11th, called the Sturgeon.
Ah, the Sturgeon
The
moon.
last of our supermoons.
Okay. Is that the second full moon or first full?
It's the last of a series of 4 supermoons.
Oh, okay. So it's a Paris, right?
Thank you, Jeff.
Thank you.
All right, well, our secretary is absent tonight, so we won't have to tell him, we don't want to hear the minutes. So we'll go straight to the treasurer report with Rich.
All right, I'll be real quick. got $3,400. We went down about 135 in the month. This is probably the lowest that will be because all our major expenses has now been paid for the year. Pretty much everything's been paid for the year. AL dues and all that kind of good stuff and insurance. But our last expense was the picnic. We just had that. And so it's all uphill from here. We had 4 new members join over the course of the month, got us up to 160 total for the roster, which is pretty good. And we recently paid out our scholarship, so there's not much money in our scholarship funds. Georgie June actually is not too bad. We had over done on there, so we almost have enough to fund next year, but we definitely need to start working on the primary scholarship. That's all I got, unless anyone has any questions, and hopefully don't want to do any auditing of the books. Good, we're good. Moving on.
Nice chair.
Can you see this on the screen?
Let me see if I can.
Yep. That's another reason we don't have as much money as normal, is because we bought
This is why we don't have as much
$2,700
money.
worth of those.
And this is how we're going to be funding that scholarship that we was just talking about. So all the officers, make sure that everybody in here, you need solar glasses. We got them, and they're a good deal, especially coming up 2023 and 2024. You spend a lot of money if you buy them somewhere else. So don't be afraid to buy them, because we got 5,000 of them.
They're $2 a piece.
Yeah,
$2 a piece.
piece, and actually we probably got about 4,960. We're making a dent. I know that.
They're on our go to our website. You can buy them, pay through PayPal.
Yeah, that code is updated now, right?
Yep.
Okay.
Yeah, a couple come through.
Why don't you announce these door prizes and explain that people have to be present to win?
Oh yeah, I got another signed copy from David Dickinson. This one is signed. So this will be tonight's prize. You got to be present to win. So sorry, everybody who's online there.
Chip.
Member of BBAA.
You have 2 chats.
And I got Bruce's laser pointer, and since he didn't show up, I mean.
You also got Bruce's t-shirt.
Hey, what? What laser pointer?
Oh, here Bruce is here. Okay.
My camera is not cooperating tonight, so you got to look at my headshot.
It looks a lot better than you are.
Yeah, definitely looks better than the live person.
Yeah, thanks a lot.
All right. So, do you have anything this month for the scholarship
No,
report
sir.
bid?
Nothing to report.
Okay, I didn't think so. We'll just roll right into Bruce then, since he's already on screen here. Bruce, give the Alcor report, please.
I have nothing significant to report for Alcor. What I would also say is I'm kind of in a stalemate in trying to restart the East Coast Star Party at Chip Oak State Park. I have cajoled, begged, and emailed several people with the Virginia Department of Conservation and Recreation. So if anybody has any friends in said state agency that would want to go to bat for us to try to get a hold of Chip Oaks. The only other thing I know to do is maybe George and I, or Sean and I, or somebody just go out to Chip Oaks some weekend and ask to talk to the management. I don't know what else to do. So anyway, I'm trying.
When you have a second, email me who you've contacted so far, and I'll try and send an email to or a call.
Okay. All right.
That helps.
So, all right, we'll do the Breezy Point event on the Norfolk Naval Base on September 3rd. Do we have access to the base for that event? Because it is inside the gate.
I am waiting to hear from the person in charge. I haven't checked my email today, so I don't know if she's responded yet. But if you don't have a military ID, I'll try to get somebody at the gate to authorize you to come in.
Okay. Well, so gate 22 over there on Granby Street is closest to Breezy Point. I keep my camper over there. If the military police do not get the word, nobody will get in. So, yeah, they're pretty strict about security these days. So just a heads up. I plan to support that event just because it's near me and I know where it is. And so, but I would point that out and just as a friendly warning.
I think last time we were there, it was just active duty and retirees that were there showing the night sky.
Okay,
I don't know if I saw the email George was talking about, but I thought that was for Fort Story, not Breezy Point. So either way, you probably, if you don't have an ID, you probably shouldn't try to volunteer at that one,
yeah,
because there's no guarantee that the communication is going to work out and you'll be able to get on the base.
right.
And if you show up and you're waiting for one of us, like if you guys see me pack up my little car, there ain't room for you to get in it.
Right.
When I come to these events, it's totally full, so there's no way for me to even help you on the base anyway, unless you're going to walk back and then ride with you on the base.
Yeah. So
Which
yeah,
they probably would frown on it too. So
Yeah.
it's probably best if you don't have a military ID just to not volunteer for that event. We do plenty of other events to volunteer at anyway.
okay. So to be clear, Breezy Point is on the Norfolk Naval Station, not Fort Story.
Yeah, we have those two events coming up. I saw the email George was talking about, and that was
Yeah,
Fort
that
Story.
was Fort Story.
Yeah,
I'll-
so
I'll
I don't think
contact-
Breezy Point is trying to make accommodations for us, but either way, probably don't want to try if you don't have a military ID.
Thanks. Sorry I couldn't make it.
No problem. Thank you, Bruce. I don't think there's any new updates on the triple RT, so we won't go into that tonight since we have a presentation. We'll go into old business. Anybody got any old business to discuss?
We have T-shirts. I got some T-shirts, small, medium, large, and extra large. Colors light blue and gray.
If anyone has ordered a T-shirt, asked me to reserve a T-shirt, and you didn't pay Rich. Otherwise, I'm going to give them to George to resell to someone else.
That's your T-shirt. They're cool. Good workout T-shirts.
Yep. I only had one item, and it was the East Coast Star Party thing. I wanted to remember to talk to you about it, but you already covered that. Anybody else have anything? You want me to stand up?
No, it's okay. I'm trying to get clear plexiglass.
I'm hiding behind it. If nobody has any other old business, let's go to the new business. Actually, I guess my item falls under old business as well. I have all the material for the solar filter workshop. If someone wants, I don't know when I'm going to be able to do it. My wife is having a surgery tomorrow. They just pushed it up. She's been incapacitated for 2 months now. So I've been doing that. So hopefully, if you guys want to wait, we can wait. If someone else wants to host the thing, I can give you the solar filter material and we can do it there. I mean, I will help, but trying to coordinate that at my house is probably not going to happen soon, at least.
But Jim did it last.
Yeah, we did at Jim's, him and Chuck hosted it over there.
Jim moved, you know.
Yeah, he lives out near me now,
He's out near,
Southern Chesapeake,
up near.
like Cortland Park area.
Right.
I'll give him a call, see if he'll post it.
Okay. I mean, I have all the material. We got it's like 2 meters of the solar filter material and just cut the size. So we should have some extra for anybody who regrets not buying in, or as the eclipse gets closer and they want to make a solar filter for their scope. So, and that's the only business I had to discuss. Anybody have anything else? I hear crickets, so I guess no. So
I see some new faces, maybe we can introduce. let them introduce.
Let's talk about exoplanets, man.
Ready for the exoplanet?
Let's do observer reports. We got 7 minutes. And then I want to be able to start the presentation. So anybody have observer reports?
I'd like to compliment Mel on that video he did of the comet. I thought that was pretty cool. He posted on Facebook. I thought that was pretty neat.
Yeah, that was a nice video.
Yeah.
It was pretty cool when he was taking it that night. You could see it just getting longer and longer, like elongating
Yeah.
out.
Yeah, appreciate
And
it.
over a short period of time, really. So, anybody else?
The solar massive outlets that's been the last couple of days.
Mhm.
Today it was like half it was bigger today, but it was thinned out quite a bit. So it looked like it was going to be disappearing by tomorrow. Or something. I don't know how fast it's going, but the difference between yesterday and today was 50% thinner. It was a thicker cloud yesterday. Today was much thinner, but it was further apart between its legs. And it was higher off the surface. So it was it's a pretty massive thing that's happening.
I heard it was like the distance of, it was like 250,000 mile solar prominence is what someone said on the group's
I'm not sure
IO.
what that number is from, because what I was seeing on other people's, if you go to space weather on the
Mhm.
other people's photos of it, they have a scale behind it, and it was showing like 100,000 kilometers off the surface. What they were showing on their scales, I'm not sure what's correct.
Still pretty impressive.
Yeah, yes.
Very cool. Thank you. Anybody else got any observer reports? I know it turned out pretty good at Skywatch. We thought it was going to be cloudy when Mel took the comment video, and I'd say the first 2 hours of the event did not look promising, and then it cleared off really nicely when sky got darker, and we were able to show a bunch of good stuff. It was very busy there too. There was probably 15 amateur astronomers there, and a lot of the public. There was families, a couple of families with telescopes that I saw. It was just really busy. A lot of people there. It was good.
That was like garden stars cleared up when I got back to my house.
Yeah, Garden Stars was cloudy when we started out. We had about 18 or 20 people there. We had
All 3 sides.
6 astronomers there. We had Tom Flatley, myself, Jeff Thornton,
Gabriel.
Gabriel, Sandy Paxson, and somebody else. I can't remember. But anyway, we had that many telescopes, and people just, we could see the moon finally when the clouds cleared. And then by the end of the night, the whole sky was clear.
Very cool. Any of you guys at home have any observing reports?
Unfortunately, no.
Let's introduce everybody.
All right, you
It's
got
too cloudy.
like 4 minutes, Jeff.
Too hot.
We got George here. I'm
Okay,
doing 2 things at once.
we're introducing ourselves, right?
Yep.
I'm
You're
George
up.
Reynolds. I'm a member. I've been a member for 22 years and very active. I love it.
Okay, very good. We'll just go right around the room. Zoom over to you. Ah, there we go.
Okay, Ed Paris, been a member for, I think, 2 years. Learned a lot here in this club, and now I'm astrophotography, which I enjoy immensely.
Definitely a good guy. Okay, and I'll switch it over to, there we go.
I'm Loyola, longtime member, free organization, and work on the scholarship committee. And want to join in.
Very good. We got the doc in the back. Very good. Go on, keep on the back row.
Tom Flatley, I'm a solar guy, and I have an 8-inch dial.
Yeah, Bill back there. Let me see if I lost Bill. There you go.
Introductions. There you go.
So let's do.
Just say who you are.
Bill, who are you?
Yeah, we're introducing ourselves.
Okay. My apologies, I have a little bit of diabetic situation.
Okay. Let's go Russ, right? All right. And let's see, we'll go straight down to you. Okay, go.
I'm Andrew, been a member for about 4 years, but fairly inactive. So I have an 11, so that's not.
Very good. Okay. Moving right along.
I'm Kevin. I would like to become a member. I'm new tonight, and I have a couple of small telescopes.
Welcome to Kevin.
Teacher.
I used to, I'm retired.
I'm sorry?
I'm retired.
Oh, cool. Good place.
Very good. Okay.
Hi, I'm Leah Flax. I teach here with Kevin. And I teach physics and astronomy. And this is Sam.
Okay. So Sam, hello, Leah. All right. I'm gonna be last. Oh, I lost my place. Go down, go down, go down. Go right. Down. Okay, I got you.
Hi, I'm Anna. My second meeting for about a month as well. And I have a restaurant.
Very good. I'll get over by hand. So moving around. Hi, I'm Jeff Goldstein. I'm the club vice president, and I'm trying very hard.
Go that way, Jeff.
Oh, I can't even see.
Oh.
Now,
There you go.
There you go.
Okay, there you are. I'm smart. Look at all these cupcakes.
Need a high-speed pencil.
I gotta go right.
And one last thing, obviously you guys know I'm Sean, but I just picked up another telescope. So if you want a telescope, let me know because I have them.
How many?
I've got two like 5-inch Meads that are on equatorials. And realistically, the mount needs thrown away. And Dobsonian base needs made for them, okay, because they're not very good. But one of them might be salvageable. I've got
Refractor, refractor, reflector.
they are reflectors. I've got an ETX 90 that I'm going to give to James. I think he's on. I saw him earlier on the call. He's going to try to fix it up and use it. I've got a C8 that I'm going to give to Rachel at Boardwalk. I have a club telescope if you want to borrow the Mead that we used to take out all the time before we got another big one. And really, I have the other big one. If someone wants to take that thing, you see me take the like Skywatch and the Boardwalk last time, let me know. It's a C11 and it's on a quartz drive mount, but it is good. Even though it's old, it is good.
Solar telescope, who has it, and how do you borrow it?
I have one and Jeff Thornton has one, and you can use it. Just if you use it, make sure you bring it to Saturday, Sunday. That's all we say is bring it to Saturday, Sunday. But we both have one and feel free to use it. And in fact, with the solar filter material, we did have the first one I tested with the solar filter material was which is beta planetary material, was on a C8 that I gave to another member, and we will make one for the C11. It's easy to make these filters. We'll make it. I got lots of foam board. We'll make it happen. If you guys need one, you may take whatever telescope you got and turn it into a solar
What solar
telescope.
scopes do you have, Coronados?
We have the PST.
Coronado PSC.
Yeah, the Cornell
Times two.
PSTs, yeah, times two. They're the identical. And they're both in really good shape. But I have other telescopes too. So please let me know. I did just get an Orion 6-inch Dobsonian too. And it's good. The guy who donated that just his wife passed away and he didn't have any interest in doing it without him, and he donated, he gave it in the original box, and he's had the thing like 25 years, so it's in good shape, it came with all the equipment. So if you guys know someone like, it's perfect for a child, I think, because that's what George probably started his grandkids out with, a 6 or 8 inch. So it's one of those nice, long, tall Orion Dobsonians. It's a good one. If no one takes that one, I'm gonna save it for George June, and we'll throw it in there in our raffle.
There's 2 chats. I've been up there for a while.
Okay. And also Sam printed these stickers for me. She has some extra sticker paper, so feel free if you want some. There's a whole envelope here.
Very good.
Okay, well, we're gonna go into the presentation now.
Those chats, super chats.
Those 2 chats.
Bruce Powers is up, and we need to coordinate with the base to get access. Okay. Covered that. You ready, Rich, to do your thing?
Well, I wasn't planning on doing much of a thing. But as a lot of you know, I'm very involved with the AAVSO, but I kind of specialize in the old long period variable stars. So instead of me talking about old dying stars that I've done many times, I thought it'd be more interesting as Dennis, if you would come and speak to our club, because Dennis has done a lot of great work on coordinating amateurs in the field of exoplanets. And it's amazing how much amateurs are doing in this field and how much you can do with the type of equipment that all of us have. So I'm going to turn it over to Dennis to talk more about what's going on in this realm that's really very new and very exciting what people are doing.
Okay, thank you, Richard. Well, I'm up here in Annapolis, Maryland, and we are having a pretty severe storm going through here. So if I lose you, we have a backup plan where Richard has my presentation and I will call in via cell phone and walk things through. So let me, hopefully I can share my screen here. Let me move everything out of the way here. Okay, can everybody see that?
Yes.
Okay, all right. Before I begin, let me just say a few words about my own personal journey to the point of observing exoplanets from my backyard telescope. About 7 years ago, I was really into planetary observing. And at that point, Saturn and Jupiter had sort of gone below the horizon, so there wasn't much viewing. But on the Alpo forum, which I was on, one of the fellows there said, well, why doesn't everybody just start looking at exoplanets? And this is now 7 years ago when we hardly even had any professionals involved to a great extent in those activities. And I thought, wait a minute, really? I mean, from a backyard telescope, being able to observe a planet going around a distant star, but lo and behold, we're able to do that. Now, I'll talk in a minute about what we mean by observing. It's not like you're actually seeing a planet like, like Earth and mountains and that sort of thing. But what we are able to detect, as we'll see, is in fact a planet going around a distant star. What I'd like to do this evening is to talk about specifically the role that amateur astronomers have played in exoplanet discoveries. And I use the word indispensable, as I hope you'll see in a minute why that's true, especially in the recent
Did we lose them right at the get to the good stuff?
Yeah.
It looks that way.
Yeah, everything was holding until you go to start. Well, I'll get his presentation ready for see if when he calls in.
Oh. Yeah, I guess.
Yeah, he may go into more detail, but it was in the abstract I put on, but Dennis has done a lot of legit stuff, coordinating NASA projects. Here we go. He's calling back in.
It's Velcro on the back. So,
Yeah.
talk about this is glare.
Yeah,
Just so we're-
you can't see the prez.
All right, well, I'll share my screen.
Thank you, sir.
I didn't realize it was messing up.
Okay, Richard, can you hear me okay?
With my
Yep, I hear you.
Shut these doors.
All right. So let me, obviously I lost power here. So let me see if we can step through it and try to do it this way. So Richard, I'll just sort of cue you to the next slide.
Yep.
So with that, let me jump right into it. Richard, if you go to the next slide. Let me say a few words about the AVSO, American Association of Variable Star Observers. It's an international organization of us amateurs. And the key there is that we're involved with advancing the science of astronomy. And we do that in a number of ways through professional amateur collaborations. We have databases of long-term observations that the professionals use. We have publications in the Journal of the AVSO that both our members as well as professionals are involved with. Next bullet there, Richard, thank you. We also provide various tools, training, support, resources that help our members do science grade observations. And the key here is that we're involved with doing science, not just taking nice pictures of galaxies and that sort of thing. We have a biannual meeting where we interact both in person and virtually. In fact, one is coming up here in November. Next one, Richard. And finally, we have sections. The AVSO sections are basically our own little communities of folks to get together where we provide interaction among members on particular topics. We have forums where folks can post questions or comments. So we have very, very involved methods for staying in touch with areas of interest that our members might have. Next slide, Richard. Here are a list of some of the sections. You see there's 12 of them or so. And they range from everything from sort of traditional variable star observing to exoplanets, which we're going to talk about in a minute, to particular aspects of variable stars, solar observing. We recently added a spectroscopy section. And also we have a section primarily involved on instrumentation and essentially taking a look at things like different techniques for using CMOS cameras, CCD cameras, different kinds of filters that are best to use. So we have a range of sections that should fit just about any amateur's interest. But again, the basis for all of this is science and helping to advance the science of astronomy. Next section. And in particular, the exoplanet section. The section provides training and support for conducting exoplanet observations. Again, these can be done with backyard telescopes. We have some observers with as small as 4-inch telescopes doing exoplanet observing. We have a database for storing our observations for long-term archiving. And other resources include courses that we offer online, an observing guide, target lists, alerts, and so on. The last bullet we'll talk a little bit more about this, but the latest space telescope that's been involved with exoplanet discoveries is TESS, the Transiting Exoplanet Survey Satellite. And one of the things that we've done is to work with the TESS science team to develop a qualification process whereby our members now are formal participants with the TESS science team, literally side by side, working with the professionals to help confirm exoplanets. Next slide. So I want to say a few words about the big picture, because we kind of get wrapped up sometimes with the sort of nuts and bolts of what we're doing observing wise, and kind of lose sight sometimes of what this is all about. The whole purpose really of NASA's exoplanet discovery missions is ultimately to see if there's some planets outside our solar systems that support life. And we'll talk a minute about what we mean by life. Next. So some related questions that we have to ask in order to determine whether a planet can support life. Is it rocky? Does the planet support liquid water? Does it have an atmosphere? Does the atmosphere contain what we call biosignatures? That is to say, some indication that there are elements in the atmosphere that indicate that life has existed or does exist on the planet. Now, one of the interesting things about biosignatures these days is that sorry, let me go back to real time. Sorry. Okay. So one of the things, well, I'm sorry, let me just turn this on. One of the things that, yep, it's still on, sorry.
Good, good. Two connections.
He's muted. He's muted his phone.
You kill it. Hopefully that's okay. Okay, so one of the things that has been a little controversial is is a biosignature, that so-called biosignature that we see in the atmosphere, something caused by biological processes or abiologic. That is to say, folks now are seeing that even though we might find things like oxygen and methane in exoplanet atmospheres, it could be that those are caused by things that are due to changes of the physical properties of the planet as opposed to living organisms. So that's a big controversy going on right now with exoplanet scientists. Okay, next slide. And the question is, what forms of life actually might exist? Let me say a few words about something called extremophiles. These are on Earth little creatures. In this case, it's we have here a little tardigrade, or sometimes called a little woolly bear, that's 0.5 millimeter long, that lives and lives off of hydrothermal vents in the bottom of the oceans. And we now have found that they can withstand radiation as well as extreme pressure and temperature. So here we have an example of, quote, life that exists in some very, very extreme circumstances. Next slide. And the question then is, if we look at something like Saturn's moon, Enceladus, which we now believe has an ocean under a crusty mantle. We know that because we see some venting of that. The question is, can something like a tardigrade, next click there, can it exist in something like an ocean on even one of our moons in our solar system? So the whole question of what is life is an interesting question. And with water everywhere now, we know that water exists on exoplanets as well as in the atmosphere of exoplanets. The question is there enough both water as well as other conditions to support life? So the whole point of this is to keep in mind that we're trying to get to the point of discovering whether or not there are sufficient conditions for life. Not that we'll be able to ever see it or experience it or touch it or feel it, but at least coming to some conclusion about whether at least all of the characteristics that would support life, in fact, do exist on an exoplanet. Next slide. So if we take a look at the night sky, click, and we take a look at every star up there, we now know that most stars host one or more planets. Click, and go ahead, Rich. Some of the orientations are such that the planets go around in a circular motion. Next. Some are a little bit more elliptical. Next. And some go across the star in our line of sight. These are this is the population of exoplanets that we're concerned with here, because these are the ones that we can detect indirectly passing in front of the light of the star. Next. So if we take a look at different kinds of exoplanets, most of the exoplanets that have been discovered so far are what we call hot Jupiters. These are large, close-in planets near their host star. And for that reason, because they are of Jupiter size, we call them hot Jupiters. Next. We have some systems that have multiple planets. TRAPPIST-1 is by far the most interesting one, that has 7 planets going around its host star. Next. We have some planets that orbit a star in a multi-star system, where we have 2 stars orbiting each other, where an exoplanet is going around one of those stars. Next. We have some planets that are free floating, that have been ejected, for example, from their original solar system and are floating free in space. Next. And we have some planets whose orbits are actually opposite from the rotation of their host star. And that's to say they're in this reverse orbital direction, probably because they were captured by their host star and are therefore not part of the original protoplanetary disk that created the star. Next. And finally, we have some stars we've identified that have planets that are disintegrating around them. And we see that through a sort of ring of varying degrees of light as this disintegrating path of material passing in front of the star. Next. So back to what we are involved in as amateurs, and actually what most of the professional community is involved in, which is that particular kind of planet that is transiting across the face of the star. And we use something called the transit method. And if one were to, in fact, take a look at the light of that host star, one would see that sort of bucket-shaped curve that you see at the bottom there, where there's a dip as the planet passes near the limb of the star. It's fully in front of the star, which is at the bottom of the bucket, and then it exits the star. We call that initial dip the ingress, and the last part of it an egress. Next. Now, we can learn a lot from our observations. And again, this, what you're seeing here actually is an observation I made of an exoplanet from my 11-inch backyard telescope. This is a particular exoplanet called WASP-12. And the key characteristics of the light curve tell us a lot about the planet. That is to say, the duration of the light curve, the depth of the light curve, even the shape of the light curve. Next. The things that we can detect or that we can ascertain by looking at the light curve would be, for example, the radius or the size of the planet. Next. The size of the orbit. Next. And the inclination of the orbit from our line of sight, simply from the light curve. So we get a lot of information about the planet. Now we get, as I said, the radius of the planet, but what we don't get is the mass of the planet. And we can't get that with the transit method. There's another method that astronomers use called the radial velocity method that give us the mass. But once we have the radius and once we have the mass, we can estimate the density. And that gets back to one of our original questions, which is the planet rocky? So if we have both of those parameters, we're able to determine then the density, and therefore, if in fact it's a rocky planet or if it's a gaseous planet. Next. So let me say a few words about TESS, Transit Exoplanet Survey Satellite. Next. And as the name implies, it's doing a survey, an all-sky survey, where it has 4 cameras that dwell on a region of the sky for 27 days, goes to the next region. And after 2 years, it's able to completely do a survey of both the northern and southern celestial sphere. TESS is now in its 4th year, so it's actually done this twice. So it has actually now surveyed the entire celestial sphere, with the exception of a small swatch in the middle. It's been able to do that twice now, which means it's been able to revisit some of the exoplanets that it originally had observed. Next. So the TESS mission itself was launched 4 years ago, as I said, and its primary mission was to look at nearby bright stars. By nearby, we mean within 30 to 300 light years. Next. And the whole purpose, or one of the main purposes of TESS, was to find candidates for the James Webb Space Telescope, which, as you know, was just launched just recently, is now in science operation. And the reason for that is because one of the main missions of JWST is to look in the infrared or near infrared at a planet as it transits a host star, and to look at signatures in the near infrared that give an indication of what are the elements in that atmosphere. So that gets back to one of the questions we had earlier about biosignatures. So JWST will help characterize the atmospheres of the planets that TESS has identified. So far, TESS has found 5,800 candidates and has confirmed 231 of them. We'll see in a minute that the whole confirmation process from being a candidate to confirm is a very rigorous process. And this is where amateur astronomers play a big role. Next. And the reason for that is because we need to do ground-based observing. Now, why do we need to do ground-based observing? We have this wonderful telescope up in space. It's above our atmosphere. But the problem is that in doing a all-sky survey, TESS has very large pixels. And because of that, as we'll see in an example in a minute, light from multiple stars get blended together in a TESS image. So a dip in light that's caused by a exoplanet transit might be actually a false positive. What might appear to be an exoplanet transit might actually be a false positive. And what we need then are ground-based observers to follow up and to sort out what's a true exoplanet transit from a false positive. Next. The process for confirming an exoplanet, as I said, is very rigorous. It starts at the top with ground-based observing. Once a candidate passes through that filter, if you will, there's some high-resolution imaging that's done, spectroscopy is done, radio velocity is done to measure the planet's mass. So it's the first part of that, next, that amateur astronomers are involved in. So we, on the ground, are observing the candidates that TESS has identified to help determine whether in fact they're false positives or not. Next. Now, let me kind of dwell on that a little bit more to give you a feel for some actual examples here. This is an image I took of a candidate exoplanet. And again, this is a ground-based CCD image. Next. If we zoom in to those two stars in the middle, next, you'll see that the pixel size of, for example, my camera is what you see there. It's about 1 arcsecond per pixel. However, if you were to take a look at a pixel that TESS has of those same stars, next, you'll see that its pixel, and again, we're talking about a single pixel here, is 21 arcseconds. So the TESS pixel is so large that for the most part is covering multiple stars. Next. So the light from those stars get blended together. So light in a single TESS pixel, we're not able to discern whether any changes in light are coming from one star or the other. Next. And the problem gets even worse. If we zoom out a little bit and see that that TESS pixel is in the middle covering 2 stars, those of you who are familiar with photometry, where we put a so-called aperture around an area and then look at the light in that aperture, the TESS aperture even consists of multiple pixels. Next. And so the TESS aperture, go ahead, click again. The TESS aperture even covers more pixels. So the problem gets even worse. So the bottom line is with the large pixel size that TESS has and the large photometric aperture, there's a lot of blending of light going on. And so if there's a dip in light of that area, TESS in many cases is not resolvable enough to determine where and if that light is being caused by an exoplanet. Next. Now, some of the conditions that cause false positives that we use our ground-based observing to distinguish have to do with a number of cases. One is where we have a target star on the left, and next to it is a nearby eclipsing binary. That's to say 2 stars that are eclipsing each other. From a ground-based point of view, we're able to separate those out to see where any dip in light is occurring. In this case, it's occurring on the eclipsing binary. However, TESS will see both of these objects together and won't be able to distinguish where the dip in light is coming from. So this is one case. Next. The second case is where the nearby eclipsing binary is so close to the target star that even our amateur astronomer scopes cannot resolve the difference. What we then have to do is to rely on a little bit larger professional telescopes. But for the most part, we're able to detect the very first case here. And that in fact is one of the dominant cases for false positives. Next. Another example is where there is a star that is orbiting a nearby eclipsing binary. And again, we still have that same problem of blending. Next. We have the case of the host star is an eclipsing binary and it's being blended with a neighbor. Next. And the case of, we just have a regular old eclipsing binary, but the secondary star is so small that when it's going in front of its host star, it's mimicking an exoplanet. Next. And finally, a case where the secondary star is grazing the primary star and it even further looks like an exoplanet. So all of these cases are ones that we amateur astronomers are looking at on our ground-based telescopes and providing data to NASA to help make the distinction about whether it's a false positive or a true exoplanet. Next. Now, I mentioned earlier that the light curve itself is very valuable in helping us to determine not only the parameters about exoplanets, but also whether there's false positives. If we see, for example, a bucket-shaped curve, more than likely that's an exoplanet. If we see a very sharp V-shaped curve, more than likely it's an eclipsing binary. Next. If we see alternating or odd even V-shaped curves, then again, more likely that's a eclipsing binary because we have a large and a small star eclipsing each other. So we see these different in depths. Next. If we see difference in chromaticity, that's to say, if we use a blue filter, we get a certain depth, and if we use a red filter, we get a different depth, more than likely this is an eclipsing binary because an exoplanet will cause a dip in light, but not a change relative to differences in color. So all of these things are ones that we amateur astronomers can do fairly easily to help make that distinction. Next. And finally, just the depth itself. If the depth is over a certain amount, which indicates that the radius is more than 2.5 times the radius of Jupiter, then more than likely it's not an exoplanet. It's probably a eclipsing binary. Next. So to give you an example of an actual observation, next. This was one observation done by some colleagues of mine up in upstate New York, again, amateur astronomers. And they did this in a red filter. Next. On a different epoch, about 11 eclipses later, I did an observation in a blue filter. Next. But if we combine the two, we see this chromaticity difference. And this nails, in fact, that this, in fact, was an eclipsing binary. Next. Now, to give you a quantitative idea about this, the ability for some of these false positives to look like an exoplanet, let's assume we have a target star. Let's take the case of it having a nearby eclipsing binary, where on a ground-based observer, we would see a very V-shaped curve for that nearby eclipsing binary. Next. And let's apply some numbers here. So if we have an 11 magnitude target star and a nearby eclipsing binary that together have about a 13.5 magnitude brightness, and let's say the depth is 100 parts per thousand of that eclipsing binary. So these would be something that we're seeing here on our ground-based observing. Next. If TESS were to look at this, next, what it would see would be on the right. It would see a target with a 10 parts per thousand depth. which looks very much like an exoplanet. So what Tess is seeing on the right is different from what we on Earth are able to discern, which is the separation between a target and eclipsing binary with a very sharp V-shaped curve. Okay, next, Richard. Now, one of the issues is that if we're looking at a target like we are here, because of the large aperture, photometric aperture that Tess has, we have to look at a number of different targets, potential stars around the target, to see if they are, in fact, eclipsing binaries that might be producing a false positive. So here's an example where normally it would be the case, we'd have to go and look at each one of these individual stars in green to see if in fact it's an eclipsing binary, very cumbersome process. So what we in the AVSO did was to develop a program to do this automatically for the test science team. Next. And we're able to do that. We added a feature to a data reduction software called AstroImage to be able to actually do that analysis on the order of a few minutes, whereas it was taking hours of manpower to do. So one contribution that we made to the test science team was some software to streamline their ability to test all of these different cases in the field of view of a test aperture to check whether there were, for example, any eclipsing binaries taking place. Next. And this feature was something that we added to this software package. And now it's in fact probably one of the most used features that the professionals use to help discern false positives. Next. So some of the contributions, just to summarize, that we've made to, in particular, the test mission is if you were to count the number of submissions that have occurred as far as follow-up ground-based submissions, the majority of them have been from amateur astronomers. As I said, we've developed some analysis tools. We actually developed the submission guidelines for the entire test team. We've helped with the analysis even of observations from remote professional observatories such as LCO. Next. One of the things that I kind of alluded to earlier that we make available to our members, if they're interested in exoplanet observing, is courses, both online and live, that we have. I just conducted, for example, a 6-week online course on sort of advanced exoplanet observing. There's a practical guide to exoplanet observing that is on my website. I have a reference to it later. This guide is oriented toward folks like me who started out doing imaging of, regular planets or galaxies or nebula. So somebody with some imaging experience who want to get into exoplanet observing, it sort of walks you through the best practices. And also the second half of it is a tutorial on this data reduction program I showed earlier called AstroImage. Any of you who are interested in getting into exoplanet observing, I suggest that you go to my website, take a look at some of the resources that are there. Go to our section page at the AVSO. We have a qualification program for members to participate in the test science follow-up program. Right now, we have 26 members that are qualified, that are participating in that program. So I would urge any of you who are interested in getting into exoplanet observing, we have plenty of resources to help you get involved. Next. So where's NASA going with their future exoplanet missions? Next. Well, the one you've heard about so much in the news lately is James Webb. And as it's just starting its science mission, it is now going to be taking observations in the near infrared. In fact, if you saw one of the original, I think 5 or so objects that were rolled out a couple weeks ago, one of them was an exoplanet curve showing in the near infrared the various atmospheric components of a particular exoplanet. And this is one of the key things that Webb is going to be doing, is characterizing exoplanets. So if you remember those series of questions that I outlined earlier, is the planet rocky? You know, one of the key questions is, are there biosignatures in the atmosphere? And that's where we're at now in our discovery process with exoplanets. Next. Now, coming up, hopefully in the next decade, is the Roman Space Telescope. And for the first time, we'll be able now to start directly imaging exoplanet atmospheres. So the Roman Space Telescope will take us really to the next step beyond even what Webb is able to do. Next. So to summarize, next, I hope I've sort of convinced you that amateur astronomers have already proven our value. The test mission is an example where we participated with professionals to really help them, especially in the planet confirmation process. Next. One of the things that is true in the test mission, that anybody who's involved in it, if your data is used in a discovery paper, you have the opportunity to be a co-author of that paper. Many of us now are co-authors, for example, on many papers. I probably am co-author on probably 24 papers already. So it provides for some very interesting contribution you can make, not only from an observational point of view, but also literally to be part of the scientific paper. Next. And again, this whole process of what we are doing as amateurs in exoplanet discovery has its roots in the experience we've gained in astroimaging. So any of you involved in deep sky imaging or planetary imaging, your experience is directly relatable to some of the principles in doing exoplanet observing. Next. And finally, as I mentioned, if you are interested, I encourage you to take a look at what AVSO offers in terms of helping you bring you up to speed on the best practices in exoplanet observing. Next. Here's some contact information for myself. Feel free to email me. If you just go to astrodentist.com, you'll see a example of some exoplanet images that have been taken, and the practical guide I mentioned earlier actually uses those images as an example. So you can literally download the images, and as you're walking through the guide, you can see how those images go through the whole process of calibration all the way through to detection of an exoplanet. Let me stop there. I have one more slide, but let me hold that to the end and just open it up for any questions.
I have one, Dennis. You mentioned, the equipment. What would be kind of like a basic rig? Like what kind of, do you need to have auto guiders?
Yeah.
How well does your mount have to track since you're doing these time series photometries? Any kind of filters? What would you need?
Good question. Okay, let me start with the mount, which is generally one of the most important elements of any of this. Yeah, the mount should be, you know, a pretty decent mount. I have a Losmondi P11. As far as tracking, auto guiding, definitely. And the reason for that is because when you imagine that if there's any image shift occurring, because of the precision that we're trying to get as let's say the host star that we're tracking, its light, if it moves across the field of view, because the tracking isn't quite up to snuff, it's going to land on maybe a dust mote, or it could land on pixels that, you know, dark pixels or pixels of different sensitivity. So ideally, we'd like to keep the image as stable as possible on the field of view. So definitely guiding, in particular, off-axis guiding. I actually use on-axis guiding, which is really guiding on the target star itself. And it's through a little split mirror that actually has the target star, not some star off the field of view, but the target star being used as the guide star. So definitely guiding would be important. Now, as far as the telescope itself, ideally, I would say 8-inch, preferably 11-inch or larger. I mentioned earlier, we do have some small scopes, these EV scopes that are 4 inches that are like run for roughly $4,000. Some folks are now using those for exoplanet observing. The difference is the depth you're able to detect. So with these small scopes, 4-inch scopes, you're able to detect maybe a 1% dip in light, which would be for hot Jupiters, but to detect something on the order of, let's say, mini Neptunes, for example, one would need a larger scope and, you know, pretty decent scene conditions. I mean, I'm here in Annapolis, Maryland, you know, in the suburbs, you know, some light pollution to the north, and, you know, I can do pretty good exoplanet observing from here, my 11-inch scope. As far as filters, ideally standard filters, but if it came down to it, maybe even a V filter. There's such a thing as a so-called exoplanet filter from Astrodyne. But even a clear filter, if it's a matter of just detecting whether it's a V-shaped curve or a bucket curve, even just a clear filter. As far as the camera, we have many folks now using CMOS cameras, and I have a Starlight Express camera I've had for years now, which is a CCD camera that performs quite well. So one does not need a full frame, you know, back illuminated camera to do some decent imaging. I think that, any other questions on that, Richard? Does that cover most of it?
No, that covers it pretty well. And I think anyone who's doing, as you mentioned, any kind of long duration like DSO astrophotography has the mount and guiding to do that.
Exactly. Yeah. Yeah. Even now, folks who are doing deep sky imaging who have, for example, RGB filters, we have some folks who are using even those, you know, those filters for the exoplanet observing. So
yeah, that's what I figured too. That's why I asked about the filters, because they probably don't have a photometric filter to do the chromas that you were talking about, but you can detect the dips and in the shape.
Yeah, even with a clear filter would be fine for just detecting whether there's a transit, but then getting a little bit more involved doing the chromaticity, ideally, you know, a Johnson Cousins or SDSS photometric filter. But yeah, the transition from deep sky imaging or planetary imaging to exoplanet imaging is a lot of the same principles. I mean, doing your, you know, your flats, darks, biases, calibration, all of that is the same. Any other questions?
Yeah, there's a couple here.
Question, you use prime focus or to use eyepiece projection?
Can you hear that, Dennis?
No, could you repeat the question? I'm sorry.
I wanted to know if he uses prime focus for imaging or eyepiece projection.
Do you use prime focus or eyepiece projection?
Prime focus, in other words, the camera, let me just make sure I got the terms right. The camera on the end of the telescope, not projected onto something, if that was the question.
Yes.
Yes, that was the question.
Yeah.
And there's another one.
Dennis, thank you for a great presentation and a great write-up too on your, can you hear me okay?
Yeah, go ahead. Yeah.
Actually, I got 5 questions, if that's okay. I was intrigued about the tilt on the exoplanets. Have you found them to be equally dispersed, or is there a bias with the expanding, global universe type stuff? Were they equally dispersed in the tilt angle, or is there a bias?
You're talking about the inclination? We
Yes,
say
sir.
too.
Yeah.
No, they're equally distributed. I mean, there's some that are dead on, straight line of sight. There are others that are so much tilted that they're kind of grazing the planet. I mean, when you think about it, it's the observations that we see are kind of biased towards more that are on our line of sight because they're easier to detect. But when you think about it, the orbits are just, can be any direction probably. I don't know what the statistics are, but, I don't think there's any particular orientation, except we just happen to be biased to ones that are, more straight on our line of sight.
Gotcha. Next question. In terms of the minor planet, I've done some minor planet work, and the saturation with the full sky surveys are kind of knocking out a lot of amateurs out of that field. Is the all sky surveys, is there any work to automate that to track, not knowing the timeline for exoplanet work on the persistency that you're actually tracking, the dip? But are the all sky surveys able to do that, and therefore kind of taking part of the chunk out of the amateur astronomer contributions?
Are you talking about ground-based all sky surveys?
Yes, sir.
There was actually a ground-based all sky survey called KELT that was done, but it didn't have the resolution that even our amateur astronomer scope have. So I don't know if that answers your question, but
I might say a little about that too, because if you look at all the surveys, like Assassin is a big all-sky survey, they survey every patch of the sky once per night. That's their goal, and they get pretty close. Sometimes it'll be 2 a night. So when you're looking for these transits, you're really taking photometry of the same area over and over for a longer period of time. And so there's no survey out there that I know of currently that's really doing that. They're sweeping the sky and moving along, where you're picking out, if you're doing this, specific targets that's sitting on it on pretty much all night to get that dip. So you're doing 2 different things. You're right that the surveys are pushing out a lot of observations in a lot of other areas, especially if you look at something like I do with longer term LPVs. That's taken a lot of that over, but I don't think exoplanets is going to be anytime soon, or even eclipsing binary work. They're very similar.
Your goal is amateur imaging. You're really going for a long, continuous, constant imaging overnight.
yeah, in fact, typically 6 hours.
Wow. Okay. Good. Thank you.
Yeah.
Awesome. In terms of the scope, Schmidt-Cassegrain, RC, corrected Doppler, anything? Is there any bias or preference in that?
No, I think all of them have been used. I think aperture size is probably the key though, but yeah.
And then what's your recommended arc seconds per pixel for imaging?
Well, it's also a function of your seeing. I have 1 arc second per pixel is the image scale that I use here. Yeah, and that works fine. So I think it, again, if you can get better, it depends on your seeing conditions.
And I had interfaced with Arnie Hendon several years ago. Is he still with the program? He was working.
Oh yeah, Arnie's still around. Oh yeah.
he had a CCD book that I did a little contribution for him. Did that ever get published or?
There's a guide, CCD guide to photometry that the AVSO has as one of its resources that I'm sure Arnie was a big part of.
They also sell his, he did a school, it's like
Yeah.
it's a I think there's, CDs, they may have digitized it at some point, but it's like hours and hours of training that you can, I think you can purchase it.
Yeah, on transformations and other
Yeah.
things, yeah.
Thank you, Dennis. That was great.
Sure.
Question in the chat.
Yeah, Bruce has got a question in the chat. I saw.
Hi, can you hear me okay?
Yeah,
Yeah, Mr. Conti, thanks for a fantastic presentation and thanks for your time tonight. So I don't have a big expensive astrophotography setup, but if I'm ever fortunate enough to retire in my lifetime, I've had my eye on these unistellar EV scopes, which are kind of the next generation of imaging telescopes, and they advertise a worldwide network of anybody that happens to drop $6,000 on the scope can network to find exoplanets. And I'm staring at this web page that they presented at a NASA test conference and so forth. So what's your opinion of the unistellar EV scope and its contributions to this? Is that
right. So if you recall, I mentioned earlier that we have folks who using a 4-inch scope. That's an EV scope.
okay?
But let me just caution you with this. As I said, those scopes, those 4-inch scopes, they are fixed exposure time of 4 seconds. It's like 3.9 seconds, and you got to live with that, which means that you've got to take, in some cases, 4,000 images over a period of time to do an exo across a 6-hour period, for example, or whatever 4 seconds comes to over 6 hours. Which means that the volume of images is huge. Now, the way that EV scopes operate, or unistellar, I should say, operate, is your data is uploaded to them. And the observer does not do the analysis, except more recently. Let me qualify that. What has happened previously is that data is sent to SETI, and folks there have been doing the analysis. More recently, in fact, in the training program I just did, there were a couple of individuals who had EV scopes that were learning how to do exoplanet analysis. But the process is still getting worked out of how you would get images that you took after they're uploaded to Unistellar. Those then have to be downloaded back to you if you're going to be doing the analysis. And they're working out right now how to streamline that. But that's right now one of the complications is getting your own images back to you because they're automatically uploaded to the Unistellar network. So I don't know if that makes sense, but basically there's not a lot of exoplanet observing going on right now. There's a few folks who are doing it. There's probably more that are going to start doing it, but there's a little process flow that has to get ironed out a little bit more efficiently.
I see. Okay, thanks very much. Yeah, at my job, I analyze my own data. So
Yeah. And as I said, those small scopes are good for maybe 1% transits, which are like the hot Jupiter size exoplanets, but tougher for some of the smaller exoplanets.
sure. Thank you very much.
Sure.
Dennis, another question. What is the typical cycle time then? Is it like planet Earth? It's going to take a year, and therefore to get confirmation, you're going to have 2 or 3 years to create a light curve. What is there a typical life cycle or cycle?
Yeah, no, actually a lot quicker. First of all, TESS will identify a candidate if it has seen 2 eclipses. And now, because we're talking about planets that are close in to their star, in one of those 27 days that TESS is dwelling on a particular part of the sky, it would have to see 2 eclipses, which means, 13 days at most of a period. Once those eclipses have been seen, if they have been seen, then it goes into the test pipeline, which is pretty quick. The test science team pops it out maybe in, I'm going to say, a few weeks as a candidate. Then it starts going through that pipeline confirmation process. That could go anywhere from, 4 months to a year, depending upon what resources are available. But in some cases, maybe 6 months. So it's really the longest period of time is just going through that rigorous process. And that's where the time is. And then, of course, writing up a discovery paper, that probably even takes longer.
So that applies to our kind of solar system. You're talking about a Mercury, Venus type, or even sub Mercury, Venus, even closer in terms of the period around the sun.
Oh, yeah, much closer than even Venus. Yeah, we're talking days of orbit around the host star.
So is that the precursor then? In other words, they pick something up, therefore they now there's a planet surrounding it, and then you assume there are other in the Goldilocks zone and all that other stuff? Or are there multiple passes?
Yeah, well, so when the first planet is identified, usually it's the one that's closest in. And depending upon the host star, let me give you an example. What TESS is focused on mostly are M stars, which are cooler stars, which means that the planet can be closer in and therefore in the, as you said, the Goldilocks zone or the habitable zone. So one of the nice things about the TESS survey is picking up planets that have a higher chance of being in the habitable zone because they're around cool stars and therefore the planets can be closer in, which means we can more easily detect them via transit method. So yeah, so typically after the first planet is identified, then folks kind of think there's probably a higher probability there's other planets out there. So they're looking for the existence of other planets, either through transits, other transits that they periodically see, or through what are called transit timing variations. If they see that the time of the orbit of a particular exoplanet slowly changes, that says it's probably being perturbed by some other planet. And so that's a hint that maybe there's a second planet. So yeah, typically the closest in planet is discovered first, and then later the planets further out are discovered.
Have any of the amateurs picked up a second light curve? In other words, 2 planetary hits?
I'm sorry, say again?
Have any of the amateurs in the team picked up any 2 light curve hits, so 2 planets orbiting? In other words, oh my God, there's one at one period and another one at a different period?
Not that I'm aware of. Most because the second planet would be further out, which means its depth would be probably smaller, which means it would be harder for an amateur to detect. So yeah, I'm not aware of any. Typically, us amateurs have detected what I'll call, quote, the primary planet, that is to say the initial discovery planet.
Thank you.
Sure. Any other questions?
I don't see any hands raised on this.
Okay, let me go to the last slide, Richard, if you could put it up. So one of the things that we're offering as we do these sorts of presentations to local clubs is a special offer of reduced membership rate of $40 for the first year. Usually the regular membership fee is $85. And what that gives you is access to all of the different forums, all the different tools. And if you are interested, just shoot an email to avso@avso.org, put club membership in the subject line, and in the body of the email, your name and name of the astronomy club. And someone will get back to you with application form. So we're offering this as we're sort of doing these kinds of presentations to local astronomy clubs to get the word out about the AVSO and to encourage folks to, quite frankly, to join the AVSO. So hopefully some of you might be interested enough to take advantage of that. Okay, any other questions? Okay, well, I want to thank Richard for helping me with this fallback presentation here, being able to do it locally there. Thank you much.
Happy to be useful.
Thank you. Okay. Thank you.
Thank you,
Thanks,
Dennis. All right, I'm just gonna do the raffle.
Time for the drawing for the door prize. Okay. We have David Dickinson's Backyard Astronomer's Field Guide, autographed copy. And we're going to give away as well 2 copies of the James Webb Space Telescope from NASA. And on the back, it explains about the Space Telescope. What I'll do is we'll draw 3 numbers or 3 tickets. I'll let you choose which of these that you want. Got 2 of these, 1 of these. If you don't need the book, you might want the picture. Okay, does anybody not get a ticket? Okay, I'm gonna shake them up. Emma, draw one out of the
Pretty
hat.
good odds of winning something this round.
The number is
3671423.
Oh my gosh.
423.
Hey, that's me.
Okay, come up
Oh,
with
not in the book.
choose your thing.
Signed book.
I signed book.
Right.
Leah Flax gets the book.
You pull their own number.
Okay.
Sounds like an inside job.
Don't worry, I got another one.
3671416.
16.
416.
All right.
All right.
We got Andrew. One more coming up. Anna's trying to get her own number
I was
here.
1 away.
Redo.
Oh, no, what's after? 3671418.
418. Very good, very good. We also have some.
Mr. Webb, I request your.
Hold on, I got a pen, I'll take care of
We
that.
also have some NASA lithographs, solar system with information facts on the back, but we're not gonna raffle these off. If you want one, we've got several, just pick one up on the way out.
Don't forget to get a sticker if you want one.
Oh, yeah.
Thank you very much, Sam, for doing that.
Stickers, if you want a sticker.
Oh yeah, there's stuff over here too. Help yourself, there's bookmarks, magic stickers.
You have to cut the stickers or what?
I'm practicing my
Peel
banner.
off.
You get a whole sheet up.
Sam, do those just peel off
Yeah.
one at a time? Or you take a sheet,
You take a whole sheet, you can peel off.
All your car.
just stick it all over on your way out the
And
building?
then right off your car. tax bill.
Oh, one other thing I wanted to mention too, it was brought up to me at Boardwalk that one of the other members, I think it was Dale Carey, was wearing like a shirt he had made, a Back Bay Amateur Astronomer shirt. And if any of you artistic people want to design a shirt,
Oh, that's me.
please submit it.
I'm really into that.
We're not set on any particular shirt design. I mean, we're going to have some other shirts made up soon and we'll take all inputs. So,
Did we lose Dennis?
no, he's still there.
Hey, Dennis, one more question, sir. You lost him?
No,
Sure,
he's-
yeah, no, I'm here. Go ahead.
In terms of the persistent imaging you do you do like, if the skies are right, do you do it like from sunset, sunrise, if you have the scope and the data and the bandwidth and all that stuff, or does things get weird lower down? In other words, is there a cutoff angle for you in terms of elevation?
Yeah, well, I typically, just like, any of us doing other kinds of imaging, probably at least above 30 degrees. And
I pick up Jupiter at 8 degrees, so.
yeah, Jupiter's pretty low right now.
Okay, 30 degrees. Thank you, sir.
Yep.
All right, if no one's anything else, we will adjourn the meeting. Thank you all for coming. Thank you, Dennis.
If
Do we know?
anyone has, like basic extrasolar planets that are or basic questions